Oh. All right. Example number 2. We're going to graph this by hand. What should we do? We're going to need the transformations. Okay, what are they? Okay, reflect over X. Now, the reason that it's important to say reflect over X, you guys are like, why do we always have to say that? Because in pre-calc that you learn what reflect over Y looks like. So we're going to be in the habit of saying reflect over X so that next year when there's both, you're already in the habit. Reflect over Y has a negative inside the parentheses instead of in front.
Is that only for like
It's for all of them. This year in Math 3, we only reflect over X. But when you get to pre-calc, you'll do both. And so you're going to have a good habit when you leave this class of saying reflect over X. Yeah. Okay, reflect over X, what else? Left 4, down 5. All right, what's the vertex? Marvelous. Okay. All right, what are the points that we're going to use to graph this little guy? Okay, so I'm taking all the points from this table, which are very similar to an absolute value graph, but slightly different. Do you have to memorize these? No. No, you can. You can memorize them if you want to. But if you don't memorize them, all you have to do is go back to the parent graph and plug in -2 to 2. That's all you got to do. Okay? Memorize them if you want. Odds are, if you do them a bunch, you'll have them memorized. But you don't have to memorize them. If you forget them, just go back to the graph without any transformations and just plug them in real quick. Plug in x coordinates from -2 to 2, and that will give you the points. Okay? All right, so we have the basic points. We got to start doing the transformation so we can graph this. So reflect over X, what does that do? Takes which point and does what to it? Makes Y negative because we're taking something from up and we're flipping it to down. That's an up and down movement, so that's a Y coordinate change. Take the Y coordinate, multiply it by -1. So -2, -4, -1, -1, 0, 0, 1, -1, 2, -4. Okay? Do you guys feel a little bit like you're getting back to your comfort zone of something? Like, whew, this is not new. We've done this before. Like, whew, it's not brand new. At least it's not brand new. The points are a little different. Okay. Okay, graphing I get is a little tedious, but at least it's not the first time. Like last time it was a little stressful, but this time it's like, okay, it's not completely new. Okay. How do we go left 4? Which coordinate are we going to change and how do we do it? X coordinate, and we're going to subtract 4. So take all your x coordinates, subtract 4. And then how do we go down 5? Which coordinate do we do it to and how? The y coordinate. And then how do you go down 5? Subtract. So taking all the y coordinates and subtracting 5. I have it today. Are you shocked?
Did you see Kel's teeth?
Kel, show me your teeth.
It's terrible. Look what he's missing.
He's got his teeth though, so that's cool. All right, down 5. Did you do her wrong at some point? Because that's usually how that happens, Kel.
It was a long time ago.
Okay.
Like 3 months ago.
All right. All right.
Yeah, we're still dating.
Yeah. Oh. You guys, I wrote -5 for down 5, and nobody even caught it. All right, -4 minus 5 is -9. All right. Down 5, down 5, down 5, down 5. Okay. Yeah, that was she walked in and gave you some solid shade and then just walked out. That's good. Like, dang, girl power, girl power!
I got abused. What are you talking about?
So am I not supposed to be proud of the girl power, or? So should I not send this video to your mom, or?
I forgot you were recording.
All right, Mrs. Kelt's mom, this is what happens when your son flirts with girls at school, and it does not end in his favor. I know. It's like last year when I was like, hey, Keld, I hear you're flirting with one of my students, and you said, which one? Yeah, you didn't, if you didn't automatically know, I think we could assume it was going to end up here.
I have art with two of my girlfriends. It's really awkward.
Yeah.
Don't dig so much.
Maybe just date one at a time.
Yeah.
That was in my past.
The distant past 3 months ago.
That was freshman year, too.
Oh.
That was her, and that was a whole different thing.
Uh-huh.
Wait, I know who it is.
Let the records show that Keld just called me dude.
I was dressing in class.
Sure. All right, this is an inequality, so is this dotted or solid? Solid. It's less than or equal to. And then what else do we need to do before we are done? Yes, shade. How do we know which side to shade? We're going to plug in 0. 0 less than or equal to negative 0 plus 4 squared minus 5. So I'm plugging in 0, 0, which is outside of the parabola. So instead of shading left or right, because it's not a line, we don't have like a left or right side or an up or down side, we have an inside versus outside. So this is the outside of the parabola. So let's go ahead and just simplify this a little bit. 0 plus 4 is 4. So we've got 4 squared minus 5. What is 4 squared? Okay, we got negative 16 minus 5. Negative 21. Woo, my phone is ringing. That's fun. Don't be upset. I got it from a thrift store. It's not used. It was brand spanking new when I bought it. Did you say no pun intended because I said spanking? I am definitely sending this to your mom. All right. Is 0 less than a negative? Whew. All right. So this is a false statement. That means outside is a false statement. So where are the true statements? Inside the parabola. That's where we shade. Well, that was fun. Okay. So now we're moving on to your favorite thing, domain and range. Your favorite, you guys. It's your favorite. Okay. Go ahead and turn the page. Okay, so you'll notice, all those definitions are written in for you this time. Isn't that nice? Woo! Oh, thank goodness. Okay, so the vertex is the middle of the graph. We know how to find that. Can you tell me the vertex on example 3? Negative 5, negative 6. All right, negative 5, negative 6. Okay. All right, now, if you look at the domain poster over here, everyone look at the domain poster. Domain always has to do with your x values. It's the left side of the graph to the right side of the graph. So if you look at the left side of the graph, you see an arrow. If you look at the right side of the graph, you see an arrow. Everything is included. So what's the domain for this parabola? Arrow to arrow? It's going to be, and think about it, right? If the V graphs were negative infinity to infinity, why would the U graphs be any different? They're very similar looking. They're just like, all it is like a rounded shape versus a pointy shape, right? In the middle. So the domain for every single quadratic is the same. It's negative infinity to infinity. Yeah, that's good. She'd be so proud of just that little 2 seconds. All right, now the range is interesting on quadratics because it does change every time. So for this, we're actually going to look at the bottom of the graph. What's the bottom of this graph? -6. To the top of the graph, what's the very top? Infinity. All right, and then what do we know about brackets versus parentheses? Bracket for the specific number because we can put our finger on it. What about the infinity? Parenthesis, it keeps going. Okay. Thank you, ma'am. Thank you. Marvelous. You're good. All right. Increasing, decreasing. I know you guys have been so sad that you have missed your little stick figure friend, and you are glad to have him back. So let's go ahead and put our little stick figure friend here. All right. What do we put? What's the first label that we put up here? Negative infinity. What do we put over here? Positive infinity. And then what number do we put down here? If you forget, look at the poster. What values do we use for increasing, decreasing? We use x values. So what value do we put right here? 5. So the x-coordinate of the vertex was 5, the y-coordinate of the vertex was 0, but we know that for increasing and decreasing, we only use our x values. Okay? So, what is the stick figure doing? He's walking downhill. He's decreasing. Decreasing. All right, he hits the x value of 5, and then what is he doing? He's going back up. He's increasing. Okay? So what is the answer for increasing? 5 infinity. All right. Parentheses, brackets. Do we put a bracket? Okay, now this is a question that's come up a few times, and a raccoon's life is on the line. Okay? If I cover this up, just everything but the 5, just look right there at the 5, that little dot. Is that slanted up or is it slanted down? You can't tell. So if you can't tell, you can't put a bracket there because brackets include the numbers. I can't include the 5 as a slant up if that 5 is not slanted up. I can't include the 5 as a slant down if that 5 is not slanted down. So increasing and decreasing is always parentheses, no brackets. If you put a bracket, you kill a baby raccoon. There were lots of raccoons that died on the quiz. I forgot to have us take a moment to rest in peace, so they died in vain. And then also they always die in vain, but they also did not have a moment to honor their deaths. So it was just terrible. All right. Decreasing interval. What is a decreasing interval? Negative infinity. It's over here on this side. Negative infinity, 5. So the decreasing interval, see where the word decreasing is? The decreasing interval is the stuff on either side of the word. Negative infinity, 5. That's what's on either side of the word. So that's how you can tell what the interval is. Okay. Now, let's go ahead and figure out some more maximum minimum answers. Just by kind of looking at these. So with this example, does it have a maximum or a minimum? Minimum, what's the minimum? -5, -6. For example number 4, maximum or a minimum? Minimum. What is the minimum? 5, 0. Right? If somebody asked you what the maximum was, what would you say? None. Okay. Yeah.
Wait, isn't the square that makes it different than, yeah, and
Okay. You're good. No worries. All right. Next page. We had X-intercepts and Y-intercepts. Now, I want to go back to example 3. And for example 3, we're going to find the X-intercepts and Y-intercepts because we only had one of those in the notes. Only one finding X-intercepts and Y-intercepts, and we finally did it on a calculator, not Desmos. So you need a calculator for this next part. If you need to trade me something to be able to use a calculator. Okay, so it worked? I know, I'm so good at computer and calculator stuff. Okay, so we got a graph. We plugged in the equation, hit the graph button. Now, to get to our menu, what do we type? Second trace. That gets us to our menu. Okay. Now, another word for X-intercept is what? 0. So number 2 is what we're going for. And can you guys tell what numbers the X-intercept for number 3, example 3, looks like it's in between? Yeah, -7 and -6 if you're getting really close. If you need to squint too much for that, you could say even -8 and -6. So for left bound, I'm going to type -8. And then I'm going to press enter. For right bound, I'm going to type -6. And I'm going to press enter. Use the little negative button down here. Do not use the minus button. Hold on, let me finish this and I'll show it again, okay? Type -6 and press enter. When it says guess, ignore the guess and press enter one more time. And then it will give you the answer. Okay, so I'm going to walk through that one more time. Press second trace. Go down to number 2, so you can either hit number 2 or you can go down to it on the menu. When it says left bound, type -8, and the negative you're using is this little negative right here. Just start typing. -8. Is your window set up like our window was? -8. Type -8 for left bound. Yep. Type -6. And then it should give it right to you. -6.732 is what you should be getting.
Wait, after -8.
Press enter. And then it should say right bound, and then you can press enter, -6 and press enter. Oh, invalid dimension.
Should have retyped it.
You're fine. Whenever it says invalid dimensions, I just automatically clear the memory and try it again. Second plus 712. All right, how are we doing? Are we getting it? Okay, I'll come over and help you individually, okay? To get the other one, where does the other one look like it is? What numbers is it in between? Yeah, 3 and 4, or -4 and -2 for sure. It's like somewhere in between those. As long as you can pinpoint what it's in between, you can find it. So I'm going to do second trace, find the 0 again, and I'm going to look between -4 and -3. -3.268. You can look between -4 and -3, -4 and -2. Press enter, and then it will say right bound, and then type the next number. Then press enter. You want to bring it up here? Yep. Let me see. Come up here. Okay, so you've got this in here. You've got a graph. So I'm going to trace 0. So we're going to say look between -4 for the left side, -3 for the right side, There's our answer.
Can you do it one more time so I can just like process it
So we're
again?
saying, calculator, I think the answer is between -4 and -3.
Yeah.
Look between -4 and -3.
Well, I think it did. Yeah, I think I accidentally did right bound first, and like it was.
Mm-hmm.
So how does it like? Okay.
So you just have to do the left number and the right number because we're in America. So we do left to right.
Okay.
Always smaller number first. So you just type it. So if you're looking between, the first one was between -8 and 6, so type -8. Right bound, type -6. There it is. All right. Huh? That's fine. You can close it. All right. The Y-intercept. How do you find the Y-intercept? Second trace number 1 value. What do you plug in? 0. Go ahead and do that. Second trace number 1, plug in 0. I think you have a typo because it should have been 2 and you have a 5. Oh, that's fine. All right. When you guys are doing this on the actual assignment, I will come around. I just wanted you to have a second chance to try to find those X and Y intercepts. So, is this easier than Desmos? Absolutely not. Okay, Desmos, you literally click on it and it gives you the answer. But this is the tool you're going to be able to use in the upper level math classes, SAT, ACT, AP Calculus exam, that sort of thing, which means you have to be able to do it on this if you're going to continue on in math and if you're going to take college entrance tests. Okay? Yes. I literally just said. SAT, ACT, if you continue on in math. Desmos, you literally can't use in any other class but this one. The reason it's not a scam is because Desmos is internet based. None of your other teachers in the future are going to want you to be allowed to use a calculator that is internet based on a test. That is why Desmos is not commonly used. Does that make sense? Because it's internet based. Then they're basically allowing you to use the internet on a test. It's internet based. So they're allowing you to use the internet on it. So that's why I'm saying you can only use it for this class, which is why I'm teaching you how to use this, because everybody outside of Math 3 uses this, which is why this is the... So this is not the scam. I'm not saying Desmos is a scam. I like Desmos. It's very user-friendly, but the TI-84 you have to know how to use because that's what everybody uses. Okay? If you Google it, how to do something on a TI-84, there's a million videos out there. Okay? Yeah. All right. We got one last thing. We got to do our end behavior. All right. So we have two options with a parabola, just like we did with the absolute value graph. So this should feel a little bit like deja vu. So you can have both arrows going up or both arrows going down. So we always start the end behavior the same. As x goes to negative infinity, as x goes to positive infinity. Does anyone remember what it means when I write as x goes to negative infinity? What do I mean by that? I'm looking at the left arrow. So when I look at the left arrow on this picture, is it pointing up or down? It is pointing up. So y goes to positive infinity. As I look at the right arrow, what is the right arrow doing? It is pointing up as well. Okay? For this other picture, again, we're going to say, I don't know why I started writing y. For this other picture, we're going to look at the left arrow, we're going to look at the right arrow. As you look at the left arrow, as you look at the right arrow, what are they doing? They're both going down. Negative infinity, negative infinity. So this is just like the absolute value end behavior. Either both arrows are going up or both arrows are going down. We always start at the same. Left arrow, right arrow. Okay? All right, so you are keeping these notes because in theory, when you did your video last night, you took pictures and turned it in theory, okay? I'm going to go ahead and pass out the assignment and